So today we're going to look at intersecting chords, secants, and tangents in a circle. Alright, so the important things that you're going to be using in this particular lesson are these three theorems. This theorem is going to be different than these two. So as you can see, these are what kind of segments or lines? What kind of segment in the circle is this? It's a what? A chord, right? And isn't a chord part of a secant? So these are two intersecting chords in the circle. Now, it looks like what we were doing in 10-6, where we were looking at angles, right, inside the circle, but today we're looking at segment lengths, not the angles associated with them. So we're going to find this piece, we're going to find this piece, and this piece. So we're not focusing on the angle. So you're going to have to separate the two. When you look at this picture, are we talking about this angle and this angle with those intersecting arcs, or are we talking about the chord lengths themselves? All right, and so we are talking about the chord lengths themselves. So be really, really careful that you can separate those two. So in order to figure out this problem, each chord cuts the other chord into two pieces. So all you're going to do is take these two pieces, multiply them together, and take these two pieces and multiply them together, set them equal to each other. So we're going to have A times B, and you're going to set it exactly equal to C times D. Whereas if we have two secants intersecting outside the circle, so it looks like that, angle outside the circle that we were dealing with yesterday, or day before yesterday, we are not going to be subtracting these arcs because we don't care about the angle on these problems. What I care about is this chord length and then this leftover length of that secant. This chord length and this leftover length of the secant. So these two are identical as far as I'm concerned. All you're going to do is take what's outside the circle, the piece that's outside the circle, and multiply it to the entire segment length. So outside times whole is going to equal outside times whole. And that's it. So for both of these, we're going to do, let's put it up here, outside, well, let's see if I can write better. We're going to do outside times whole equals, moving on, so outside times whole equals outside times whole. It's a Friday, isn't it? So as you look at type 2 and type 3, so type 2, what's the outside piece for here, for this length? What's the outside piece? A. So we're going to have A times, what's the whole length from here to here? It is not AB because that would be multiplying. When we measure from here to here, and then from here to here, don't we add those measurements together? So be really, really careful that you don't call that length AB. It's A plus B. And so that's your whole A plus B equals what's your outside on this length? Everybody, what's your outside? C. And then what's your whole length? C plus D. And then on type 3, let's see, we'll go with orange. On type 3, what is the outside for this length? A, right? What's the whole for this length? Isn't it also A? So when you have a tangent, the outside and the whole are the same for the tangent. And so you will end up having, the same thing times the same thing. So you have A times A. But I still view it as outside times whole equals outside times whole. So what's the outside of this length? B. And then what is the whole length from here to here? Very good, B plus C. All right, so we're going to apply those. Quite simple, right? We're going to do all the odd problems today. And then I'll have you do the evens on Whiteboard. So let's look at number 1. Solve for x. So as we're looking at the problem, notice that these refer to segment length, so I don't care about the angles or the arcs. So because I've got two secants intersecting inside the circle, we're just going to take the pieces of each segment, multiply them together, and set them equal to each other. So all we're going to do is take 14, well, I'd rather do it with a variable on the left. So let's take this length. Isn't that 10 times x? Equals, and then this length is going to be 14 times 15. So you have calculators on your desks. So tell me, what is 14 times 15?
210.
It is 210. And then divide by 10, what do you get? 21. That's not so bad, right?
That's not bad at all.
Not bad at all. Look at example 3. So example 3, the math starts to get a little bit more difficult because you start to see expressions here. So this x plus 7 belongs to this piece, and then we got a 24 for this one, a 27, and then this x plus 5. You're still just going to multiply those pieces together and those pieces together and set them equal. So we've got 27 times its other piece is x plus 5 is exactly equal to 24 times its other piece, x plus 7. Is there anybody that doesn't see where I came up with these values here? So on each side of the equation, it's the same pieces of the same segment being multiplied together. And then from there, we're just going to use our math. So we're going to distribute the 27. So 27 times x is 27x. What's 27 times 5?
135.
It is 135. Equals, and then we're going to distribute the 24. 24 times x is 24x. What is 24 times 7?
168.
It is indeed. What should we collect first? The x's. So we're going to subtract 24x, bless you. What you do to one side, you must do to the other. And so we end up with 3x plus 135 is equal to 168. Subtract your 135, what do you get?
33.
So 3x is equal to 33. And what does x equal? 11. Okay? So the same problem, just a little higher difficulty level. Look at question 5. So this time we're solving for x. Is the intersection of the two secants, these are both secants, are they inside the circle or outside the circle? Outside. So anytime it's outside the circle, think outside times whole equals outside times whole. So we're going to take the outside here, which is 9, and multiply it by the whole length. What's this whole length? 9 plus x or x plus 9. I'm kind of a traditionalist, so I'm going to write x plus 9 equals. And on the other side, what's our outside on this length? 8 times, and then what's our whole length? 8 plus 19. On the answers online, you won't see them writing 8 plus 19. They're just going to have added those together. But for your notes, I'd be adding, writing them out like this. So then we're going to distribute the 9, and we get 9x plus 81. And then 8 times, what's 8 plus 19? 27. And then what is 8 times 27? 216. So we have 9x plus 81 equals 216. So subtract your 81. We get 9x is equal to what? 135. And then divide by 9, what does x equal? 15. So any questions on the front? So if they intersect outside, it's outside times whole. If they intersect inside, it's just the two pieces of the segment multiplied together set equal to each other. We all good?
Yeah.
All right, moving forward. Next page. So this time we're going to look at 7. So for 7s, are we outside or inside the circle here? Outside, so it's outside times whole equals outside times whole. So this one's a smidgy bit more complicated because one of your segment lengths is an expression rather than just a plain variable. But it's still no different. So what's the outside portion of this one? 8. What's the whole length from here to here? 8 plus 3x plus 4. So we have 8 plus 3x plus 4. And again, on the answers online, you're not going to see that part of it, but for your notes, if I were you, I would do that. And then on the next segment, what's the outside? 7. And what's the whole length? So let's clean up what's in the parentheses before we distribute. So we have 8 times, the 8 and the 4 is 12, so I have 3x plus 12 equals 7 times, we've got 7 and 2 is 9, so we have 5x plus 9. And then we're going to distribute. So we've got the 8 going to everything inside. 8 times 3x is 24x, bless you. What's 8 times 12? 96 equals, distribute your 7. 7 times 5x is 35x. What's 7 times 9? 63. It's a Friday. So then we're going to collect our x's. So the 24x is smaller, so you should be subtracting 24x. Again, I've said this before, you do not have to have your x on the left all the time. This way we avoid negatives. So the x's cancel. We get 96 is equal to, what do we get? 11x plus 63. So subtract your 63. And we end up with, running out of room, so I'm going to move it over here. We end up with, what, 33 is equal to 11x. What does x equal? Just 3. That's almost as hard as your math is going to get. It does get a little smidgy bit more difficult. We'll talk about that at the very end. All right, so look at number 9. So 9 has a tangent, right, with a secant, and they're intersecting outside the circle. Because it's outside, we're doing outside times whole equals outside times whole. So what is the outside of the tangent? 24. So we have 24 times, what's the whole length of the tangent? So anytime you have that tangent, it's the same thing times the same thing. Equals, what is the outside of this segment? 18. And what is the whole length? 18 plus x, or x plus 18. And so then we're going to multiply. What's 24 times 24? 576 equals, and then we are going to distribute the 18 through, so we get 18x. What is 18 times 18? 324. Subtract your 324 because we already have just one x term, so we're going to subtract the 324. And we get 252, yep, is equal to 18x, divide by 18, and x is equal to 14. All right, so then I want you to set up number 11 on your own. Don't solve it, because I want to talk about some things with solving it. But go ahead and set up the equation on your own for number 11. Discuss it with your table groups, what you came up with. Okay, so let's chat about it. Danya, what did you come up with? Wait, hang on just a minute. You guys have to listen. What did you come up with? So she's got x times x equals times what? 27 plus 21. Is that what you all came up with? Okay.
Yeah.
So what's x times x?
X squared.
X squared equals, we've got 27 times, what's 27 plus 21? 48. What's 27 times 48? 1,296, right? How do you solve for x?
You find the square root.
Okay, so here's the deal. When you take the square root of both sides, we have been lazy in this because we've been solving using Pythagorean's theorem, right? However, this is no longer a triangle. X could possibly turn out to be negative, and you have to evaluate that. So x could be negative if it doesn't make the segment length itself negative, okay? So you have to remember to do a plus or a minus out here and then evaluate and maybe throw out the negative value if it doesn't work. So what I'm saying is the x is equal to either plus or minus, what's the square root of 1296? 36. Then look at your picture. This is the only place where x is. Could x be a negative 36? No. So we are going to throw out the negative part, and we are going to say that x is only equal to 36, but there are some instances where the value of x could be negative. So don't forget when you take the square root, it's plus minus. All right, I want you to set up, don't go any further, the equation for number 13. This time your chords are intersecting inside the circle. So we're different, right? Flip it to the other side. We're intersecting inside the circle. So chit chat with your table groups about how you're going to set that up. All right, so here we go. Zach, what'd you set up?
X squared 12 times x
Does the 12 and the x minus 1, are they on the same segment?
12 times 10.
Yeah, we got to do the 12 times the 10, and we have to do the x minus 1 times x plus 6, right? So keep the same segments on the same side of the equal sign. So we've got x plus 6 times x minus 1 equals 12 times 10. So don't we have a binomial times a binomial? You're going to have to FOIL it. So we're going to multiply x times x. We get x squared. X times negative 1. We get a negative x. Then we're going to multiply 6 times x, and I get a positive 6x. And then 6 times negative 1 gives me a negative 6, equals 12 times 10 is 120. Oops, I added an extra 0. Since we have an x squared, and we're going to have an x term, that implies that we have to factor. So we have to move the 120 over to the left so we have one side equaling 0. We always want our x squared term to be positive. So I'm going to subtract the 120 at the same time as collecting like terms. So I'm subtracting 120, I'm subtracting 120. And I'm going to collect my like terms. So I end up with x squared. The minus x and plus 6x gives us a positive 5x. And then the minus 6 and negative 120 is negative 126 equals 0. So let's review our factoring methods once more. So we're going to take the coefficient of the squared term, which is 1, and multiply it to the constant, which is negative 126. So we're we are going to take 1 times negative 126, and don't I get a negative 126? I am looking for a middle term of 5, so I'm looking for a positive 5. I have to find the factors of 126. Because the product's negative, we're going to subtract the factors of 126 and find 5. So most of you are not familiar with 126. We're just going to run through the factors. 1 and 126. They subtract to give you 125. That definitely can't be it. Does 2 go into 126? How many times? 63 times, right? And you subtract those, you get 61. Does 3 go into 126? What's the rule for 3? Add up your numbers. So what's 1 plus 2 plus 6? 9. Is 9 divisible by 3? And so is 9. So both 3 and 9 go into 126. So we're going to start with 3. So 3 goes in there how many times? 42. Subtract those, and I get what? 39. Does 4 go into 126? Do you know the rule? Does 4 go into 26? The last 2 digits? No, so 4 doesn't go in there. How about 5? No, because it doesn't end in 0 or 5. How about 6? See how 2 and 3 went in there? So 6 goes in there. So 6 goes in there how many times? 21. Subtract those, what do you get? 15. So we're getting closer. How about 7? Does 7 go in there? Try it. Divide 7. See what it does. How many times? 18. Subtract those. What do you get? 11. Does 8 go in there? Well, if 4 didn't go in there, 8 doesn't go in there. 4 can't go in there. 8 doesn't go in there. We already tested 9, and we know that 9 goes in there. So how many times does 9 go in there? 2 times? How many times? 14 times. I'm going to squeeze that in there. 14. And subtract that. Oh, finally we got our 5. So there they are. Right? 9 and 14. So we are going to factor this. Our x squared, because there's no coefficient, you're just going to take the square root and drop them in the first slot. So we've got x and x. And then you're going to take these factors. Oh, goodness. I did not want to do that. We've got to take these numbers and find their signs. So if I want a positive 5, so let me put some signs in there. So I want a positive 5. The bigger of these two carries that sign. So the 14 is bigger, so the 14 is positive. What does the 5 have to be to combine with a 14 to make a positive 5? Is it going to be positive or negative? If the 5 is positive, won't we have to add and keep the sign? That'll make it bigger. If the 5 is negative, don't we subtract and keep the sign of the larger? What if 5 is negative? What do we get? We get a positive 5. So your 5 has to be negative. So we're going to drop those in here, minus 5, and then a plus 14. Oh, is that a 9? Thank you. Thank you. That would make a big difference, huh? So how about a minus 9 and a positive 14? Oh, that's much better. Okay, so then we are going to set each of these equal to 0, because if you have a product that equals 0, one of these two has to equal 0. So what's x value here that's going to make it 0? What value for x here makes that 0? Set that equal to 0. What do you get? Come on, guys, it's not hard. Answer me. Everybody. X minus 9 equals 0. X has to equal 9. That's all I'm asking for. All right, so we get 9 for that one. What about this one? Negative 14. Now we have to evaluate our answers. Go back and look at each expression. For the negative. Negative 14 plus 6 gives you what? Negative 8. Can we have that? Nope. So we are going to throw out the negative 14, and we're going to keep just the x equals 9. Then I'm going to do a little erasing right here if I can. Oh, it won't let me. Darn it. All right. Fair enough. Okay, so last problem we're going to do is 15. So 15 is a little bit more complicated as we go along, and I'll show you why. So we've got, we have this outside, the intersection is outside the circle, so we're going to do outside times whole equals outside times whole. So let's set up our problems. So on this segment, our outside is what? What's our outside? 5.5. Don't let the decimal freak you out. So 5.5 times, and then our whole length, I know it's hard to see on the video now, but isn't that 22.5 plus 5.5?
Yeah.
So 22, oh, that's terrible, 22. So 22.5 plus 5.5 equals. And then on the other segment, what's the outside here? X times what's the whole length? X plus 15. So tell me, what is 22.5 plus 5.5? What is it? 28. Equals, and then we're going to distribute the x. X times x, x squared, and x times 5, 5x. What is 5.5 times 28? What is it? 154 is equal to x squared plus 5x. So we have an x squared term, we have an x term, that implies we have to have one side of the equation equal to 0.
Yeah.
Oh, you're right. 15. And then that makes that a 15 and makes that a 15, right? Good catch. I can't see. I have these new contacts. Apparently they're not working so swell.
Probably because you're wearing glasses with them.
Well, because these are far contact lenses. I can't see close up with the contact lenses.
Well, yeah,
And these are not the correct readers to go with them. So I'm making do. I'm handicapped. Give me a break. I'm going to cry. All right, so I'm going to subtract the 154 and set the left side equal to 0. Because my x squared is positive on the right, I want to keep it there. So I have 0 equals x squared plus 15x minus 154. So we're going to factor it just like we did the one above. We're going to set up our table of values. So again, we have 1 times negative 154. Put that on our t-chart. What am I looking for? I want a positive 15. And so the product of 1 times negative 154 is negative 154. Since that product is negative, we're going to subtract the factors of 154 and try to find 15. So start with 1 and 154, subtract them, we get 153. That didn't work. Does 2 go in there? How many times?
77.
How many?
77.
77. Subtract those, we get 75. It's a little bit closer. Does 3 go in there? What's the rule for 3? 1 plus 5 plus 4. What is that? 10. 10 is neither divisible by 3 or 9, so neither 3 or 9 are going to go in there. So keep going. So what about 4? Does 4 go into 54? Yes or no? Nope. So 4 doesn't go in there, which means 8's not going to go in there either. What about 5? Nope. What about 6? Did 3 go in there? Nope. What about 7? 7 goes in there because I can tell because of the 77. So 7 goes in there how many times?
22.
22 times. What happens when you subtract 22 and 7? That's what we're looking for. So methodically go through your divisibility rules. Let's find our sign. So, bless you. So I am looking for a positive 15. That's our middle term. The bigger of the two is the 22, so that's positive as well. What does the 7 have to be to combine with the 22 and make a positive 15? What is the 7 going to be, positive or negative? What is it? It has to be negative. Because if 7 were positive, you'd add and keep the sign, and you'd have 29. It's too big. So then we're going to put those values in our binomials. So the x squared becomes x and x. And then we're going to put in the minus 7 and the plus 22. And then we are going to solve for x. So if I set this equal to 0, what's the value for x? 7. Whoops, let's try that again. If I set this equal to 0, what's the value for x? Negative 22. So go back and look at your picture. This is the only place x is. Can x be negative? No. So we're going to throw out that negative value, and we are only keeping the x equals 7. So a little bit of factoring review for you on that one. Any questions? Of course it will be on your test. I expect you to know how to factor. You mastered Algebra 1, 2 to get in here, and 8 weeks of that was factoring. 8 weeks. So if you cannot factor, that's inexcusable. Plus, I've gone over it and over it and over it. At some point, you have to just take ownership and learn it. Quit being lazy.